Welcome back, dear students, to this course on BSP 403. So, as you all are aware that right now we have been discussing on this application part of operational amplifier, okay? And in the last few couple of classes, we have been discussing about the some of the few application of operational amplifier, and those are the inverting and non-inverting amplifier. Okay, we have derived the expression for the voltage gain in both the cases. Okay, so today we will continue our discussion, and we will try to see first. We will try to see the extension of your non-inverting amplifier. Okay, what else? What if we see, your non-inverting amplifier, now it will have the feedback resistor and the input resistor. Okay, so what if you change those resistances? I mean, if you slightly change the value of those resistances, then whether we can get a kind of buffer or not. Buffer is a voltage follower. Okay, so first we will discuss about that voltage follower, which is nothing but it is a special case of your non-inverting amplifier. Okay, we will see that first, and then after that I will try to discuss about the multi-stage operational amplifier. Just like you are just like your transistor amplifier you have, and then we have discussed the multi-stage transistor amplifier, is not it? One stage, two stage. Just like that, even in operational amplifier also you can have the multi-stage operational amplifier. Okay, we will try to discuss that, and I mean, after that we will try to see another application like about the summing amplifier, how we can use operational amplifier as a summer. Okay, so these three topics I would like to discuss today. So let me present the screen first, then we will continue. All right, so here we go. Let me just open the platform where I will be showing you today's class. Let me go back and close this window, otherwise it will make sound all the time. Okay, so here we go. All right, so first let me tell you something about this voltage follower. Let us see what is a voltage follower. Now see, by the name itself, you guys may just think that voltage follower, like, I mean, whatever voltage you give in the input, you will get the same thing in the output. Okay? That is known as a voltage follower. So in digital electronics in the last course, I think you guys have remembered that the basic gate, like those are the NAND gate, AND gate, and OR gate. But before that, I think I have taught you something about buffer also. Like in digital electronics, you call this as buffer. Sorry, let me try to write down a little bit lower than this one. So you know what is a buffer. Buffer means suppose you give a 0 at the input, you have a buffer here, let us say, okay, and then you will get a 0 at the output. Or you give a 1 at the input, you will get a 1 at the output. So it is something which is a kind of a follower, which we will call this in analog electronics. And this voltage follower will be an application or an extension part of your non-inverting amplifier. Okay, just we can call this as a buffer also, a buffer amplifier. Whatever input you will give, you will get the same output. Okay, just like in case of digital electronics, as I told you, in digital electronics we know something, that there is a buffer. Whatever input you give, you will get the same output. Okay, so all right, now see, you guys, you already know about non-inverting amplifier. So I have already discussed that in the last class. So I told you that this is the extension of the non-inverting amplifier. Okay, so therefore let me just try to draw the diagram of a voltage follower, and then tell you that what is the difference which we are making in designing this voltage follower. You want the same output in the output also, isn't it? So I'm making the, okay, since this is a non-inverting amplifier, so I need to give the signal here. Okay, I mean, I need to give some signal here, input signal here, whether it is V1 or V2, whatever it is. So I'm giving some signal here in the plus, and now you know that in usually in this, I mean, in non-inverting amplifier, uh, you see there is a resistance here, isn't it? There will be a resistance connected here, Ri, then that Ri is grounded, and then we will have the RF feedback resistance, and then you know what is the gain for non-inverting amplifier, that is gain closed loop. Let me write down the gain first. Okay, so this gain is 1 plus RF divided by I, isn't it? We have derived this in the last expression. Now what if I change, the configuration of this non-inverting amplifier in such a way that my gain is 1? Okay, can I do that? If I make the gain 1, how will I have to design it? This one, I mean, it's quite simple. You don't give the input resistance and you don't give the feedback resistance. Although you give the feedback path, just connect it in this way without any, I mean, your resistance. Okay. So in this case, what would I say, that RF, since this is the formula for the gain of an, I mean, a non-inverting amplifier, now we have not given any RF and RI here. Okay, we remove Ri and Rf, and we have sorted the output. We have just sorted the output. All right. So to this non-inverting, this is a non-inverting amplifier. We are making some changes in this non-inverting amplifier. Now what would be the gain of this one? Okay, now the gain would be just like ACL. So this would be equal to 1 plus 0. We are not having any RF here, isn't it? RF value is 0. So therefore, what do we get? We got the gain to be 1. Now, when you get the gain to be 1, then what will be the loop gain? The loop gain, closed loop gain is 1. What is the meaning of that? The meaning of that is like you are having the ratio, the gain is nothing but V naught by Vi. Okay, that is gain, and that is 1. So this implies that your V naught is equals to your Vi. Okay, so that means the output, whatever you are getting in the output, that is same as your input. Like it is a kind of follower. Whatever you give, it will follow that in the output, and hence the name, it is a voltage follower. Okay, so this is a very pretty. I mean, you can just include this section in the non-inverting amplifier itself. Okay, this is just an extension of non-inverting amplifier, a part of a non-inverting amplifier. Okay, so now based on non-inverting amplifier, I can try to give you some questions. Like we will try to, let us try to have a discussion rather. Okay, some kind of questions. So now you need to calculate the output. I'm just drawing a circuit diagram here. Let me try to do it quickly. Okay, so I'm just writing in short. Okay, V naught, then let us say that I have here output. So these are my plus 16 volt and minus 16 volt supply voltages, and then some input I'm giving here. That means whenever I give the input to plus, this is your non-inverting amplifier. Okay, and all right, here I am having some value of resistance. This one is grounded, and this is like your 2.4 kilo ohm. Okay, so now here you need to find out the output here. Your feedback is also given. So this value of feedback is 240. This is a very simple question actually. Okay, you need to find out the output. So how would you find out the output? By just looking at the diagram, you know now that this is a non-inverting amplifier, isn't it? So if this is a non-inverting amplifier, then first find out the gain, and then you find out the output. So once you do that, the input is given to you. Okay, input is given to you, that is 120 microvolt. Now if you know the input, you can easily find out the output. Okay, तो output और input का relation क्या है? देखो, V naught by Vi, again I will tell you, V naught by Vi is equal to the gain. Okay, now let us first find out the gain. What is the gain? ACL, closed loop gain, that is equal to 1 plus, since this is a non-inverting amplifier, so this is equal to 1 plus RF divided by RI. Okay, so now you please put the value of RF and RI. Okay, so this would be 1 plus RF is 240 and divided by 240 divided by 2.4, RI is 2.4. Both the units are in kilo ohm, so no need to just convert the unit here. So you will get the value of this gain, closed loop gain, to be, I think, around 101. Okay, so this value is 100 and this is 1. So this is 101. Now you know the gain. It's pretty simple now. Therefore, V naught is equal to your ACL into V in. Okay, and V in is in microvolt, so you can please convert it into volt and write down, or you can convert it into millivolt and write down the output. Just put the value 101 here and put this value 120 here, convert it into millivolt or volt as per your choice, and then write down the output voltage. So this is how you can do this kind of problems. Okay, I'm not going to show you the other problems here. Okay, but since what you must know that first you must check the circuit properly, like what kind of configuration it is, whether it is inverting or non-inverting, then it will be very simple for you to calculate the output voltage. Okay, so now let me move on to the next section. So maybe this kind of question I will give you some more in the notes. Okay, you can check in the notes. So now let us see one important topic before I go to the next application, that is multi-stage op amp circuit. Multi-stage op amp circuit. So let's see this. We can have different operational amplifier connected back to back, just like you are in case of your transistor amplifier. Okay, so here also we can have a different amplifier. So okay, let me just try to draw this as quick as possible. Okay, so let us say this is my minus and plus, and suppose now I will connect this stage to another stage. Okay, I will connect this to another stage in this way. So let me say this is my minus output plus, and then the output of this to again another stage I will connect through a resistance. So that will be again here. So it is minus and plus. Okay, so now this section I will make this ground. Just let us try to understand this, then we will try to see. Okay, and finally I will have the output here, V out. So as you can see that this is a 3 stage, is not it? This is the first stage, second stage, and the third stage. Okay, so now I will have some connections. So it may be inverting or non-inverting. We cannot say right now. Okay, so let me complete it first. So, and then of course there will be, so in this first stage, let me give some voltage in this first stage. So this is my voltage, and I will call this as V in or VI. Just let me write VI only. Okay, so there will be a feedback resistor here. Similarly, I will have another feedback resistor here. Okay, and similarly I will have another feedback resistor here. Yeah, so this is your circuit. Now you can design your circuit in this way also, multi-stage. You are connecting different stages from one stage to another stage. So before I proceed further, let me just quickly so let us assume that right now we are having the feedback resistance which are equal here. all these feedback resistors are value are having RF, okay, and then the input resistance which we are giving RI. This one let us say R1, and this one let us say R2, and here let us call this as R. Okay, so this is our circuit diagram. Now here you know that I'm going to ask you one thing, that whenever a transistor is connected in cascade like this, that is back to back, okay, one amplifier is connected back to another amplifier, again the output of this is connected to another amplifier. When they are connected in this cascade form, what will be the total gain? I mean, suppose let us say the gain of this one is A1, let us say the gain of this one is A2, and let us say the gain of this one is A3. So what will be the total gain here?
A1, A2.
Yes, so the total gain would be just the multiplication of all the gain, which we have studied in, I think few days back, I have told you that the gain is just the multiplication of the individual stage. If the gain of this one is A1, then the total gain would be like A1 into A2 into A3, okay? If you take the log of that one, then you can do the plus there. You can convert that unit if you want, but without the logarithmic unit, then it will be just A1 into A2 into A3. That is what do we know here, isn't it? So in this case also, I mean, you can first find out the gain of the first stage. Okay? So what will be the gain of the first stage here? Can anybody tell me now? Suppose this is my first stage amplifier, और ये मेरा second stage है, ठीक है, और ये मेरा third stage. तो अभी what will be the, I mean, the gain of first stage? A1. What is A1? Let me write down A1 here. A1. Please see only the first stage amplifier. What type of amplifier is this? And tell me the gain. You already know this. Yeah, I could not hear you properly. Just remember that this is your non-inverting amplifier. The first stage is your non-inverting amplifier because the input is given to the plus terminal. Okay, that is why the gain of this one is 1 plus, the gain of this one is 1 plus RF divided by RI, isn't it? So this is the gain of the first stage. Now what is the gain of the second stage? The gain of the second stage. You look the second stage here now. What type of amplifier is this? Is it an inverting or non-inverting amplifier? First, tell me. So this is a non-inverting amplifier because the input, whatever output is here, that will be the input here. And the input, that means the input is given to negative terminal. That means this is inverting amplifier. So for inverting amplifier, what is the formula for gain? The gain is given by A2. The gain of this second stage is nothing but minus of feedback resistance RF divided by R2. Okay, so this is the value of your A2. Similarly, you can check the value of your A3 here. A3 देखो, A3 यहाँ से start होगा. A3, this stage, that means R3 is the, this is R2, not R, this is R2, sorry, RF divided by R2. Okay, similarly here also you see the input, the output of this stage, which is the input of the third stage, the input is given to the negative, the inverting terminal. That means this stage will behave like an inverting amplifier, and we know that the gain of the inverting amplifier is given by minus of feedback resistance, which is RF, divided by the input resistance, which is R3 in this case. Okay, so now we got all the formula. A1 is 1 plus RF by RI, A2 is minus RF by R2, and A3 is minus RF by R3. Now you find out the total gain. Total gain is A1 into A2 into A3. Now if you multiply all these things, this minus and minus, it will become plus. So you will get a plus quantity actually. If you multiply all these, what do I mean to say is that this is your first part, okay? You multiply this into this minus RF by R2 and again into minus RF by R2. So this minus and minus, it will become plus. So what will be the overall gain? If I write the overall gain to be ACL, whether it is positive or negative. So the overall gain here is positive. Now, whenever the gain is positive, that means that particular amplifier, we will call it a non-inverting amplifier. So overall, if you consider all these together, so this together, it behaves like a non-inverting amplifier. Okay, because in this case, we are getting the gain to be a positive quantity. Okay, so in fact, you can give the input here and try to check yourself. Just try to first give the input here and check it whether your gain will be positive or negative. In that case, that may behave like your inverting amplifier. Okay, fine. So these formulas, you please remember this. Then solving numerical questions will also be not that much, difficult. Okay, so I have written one question, but I would not like to go through that question right now. So just using this formula, you can, you can solve many numerical questions. Suppose the value of RF is given to you. Okay, suppose the value of RF is given to you, and let us say all these value are given to you, RF, and all these value R1, R2, R3, and it is asked to you that find the total output voltage. So you guys should be able to do it. To find out the total output voltage of this multi-stage amplifier, first what you do, you calculate the individual gain first, like individual gain A1, A2, A3. After calculating the individual gain, then you product this, all this. Then you calculate the total gain. Okay. So once you calculate the total gain, you know the input already. It will be given to you in the question. Okay. Then using the gain and output, okay, the main formula for the gain, you can calculate the value of your output voltage. Okay, so I have written some of the questions here. I can provide you after this, in different platform, I can give it to you. Okay, so this is the idea about your multi-stage op-amp circuit. Okay, so we have come to the the end of this non-inverting and non-inverting amplifier. Now we will go to the different application, and this application is an important one, that is the summing amplifier. Okay, so let me go to this summing amplifier. So now we will see how operational amplifier can be used as a summer actually. So this is the third application. So we are on the third application, that is summing amplifier. All right. So that means we are going to use, we are going to use this operational amplifier as a summer in this case to add some voltages. Okay, we can use this. So to do that, so actually this summing amplifier, ये समिंग एम्पलीफायर कैसा टाइप का एम्पलीफायर है, हम लोग को पता है हमारे पास दो एम्पलीफायर है, एक तो इन्वर्टिंग एम्पलीफायर है और एक नॉन इन्वर्टिंग एम्पलीफायर है. ठीक है, तो दिस समिंग एम्पलीफायर इज योर इन्वर्टिंग एम्पलीफायर. It is a special case of inverting amplifier. I'm just writing in short. Okay, so that means I will have to give the input to the inverting terminal and I will have to ground the non-inverting terminal, isn't it? So let me try to draw the circuit first. And in this case, if it is an inverting terminal, then the voltage, output voltage should be proportional to the sum of the input voltage. Okay, should be proportional to the negative of algebraic sum of the input voltage. Suppose I am giving two input voltage, V1 and V2. Then the output should be equal to V1 plus V2. That is why it is known as the summing amplifier. Okay, output is proportional to the negative of the sum of this algebraic sum, because we are using this in inverting mode. Okay, so let me draw the diagram and let us try to understand here. I'm giving different input here. So I will draw the first, let me try to draw the input in this case. Let me say this is my input I'm giving through this resistance R1. And let me say that this is my second input I'm giving through this resistance R2. And let us say that this is our third input. Okay. Now all these input would be connected. Let me try to draw it a little bit properly. So these inputs are connected together here at this point. So I will call this as R1, this as R2, and here as R3. Now I will give separate voltages here, three voltages. That is, I will give this as V1, and this as V2, and this as V3. Okay. So since this should be a non-inverting amplifier, I will connect this input to the non-inverting terminal. I will have operational amplifier, and then I will just connect it in this way. So this is my, inverting terminal. I will connect this all to inverting terminal, and the non-inverting terminal is grounded. So this is the diagram now. See, there is not much difference here. The only difference is that instead of giving one input in the inverting amplifier, if you connect the input in this parallel way, in this parallel resistance way, then this will act like an adder, an op-amp adder. It will add all these voltages. But there is condition for adding all these voltages. We will see that condition also once we do the derivations. ठीक है? तो यहाँ पे एक feedback resistance होगा. There will be a feedback resistance here, and then I will call this as RF. Okay, and let's say we have the output obtained here. So that instead of only one input given, there are three inputs are given like this. This is the configuration. Now, one thing which you want to tell first and foremost that, so this input V1, it will produce some current here. Let us call this current as I1. Similarly, the voltage V2 will produce some current I2, and V3 will produce I3. Okay, so this current are going in this way. So now at this point, all these three current will meet now. Okay, the upper current, the middle one, and the lower one, they will meet at this point, and here we will get the total current. Okay, here we will get the total current. I1, and what is the total current? That total current, if you apply KCL here, Kirchhoff's current law here, you see that all the current are coming towards this point, towards this node. That means the current would be just the sum of these three, I1 plus I2 plus I3. Okay, because all the currents are coming towards this point. So this total current, whatever we will get here, that current is the sum of this I1 plus I2 and I3. Now this total current will flow here, and then since you know that the input impedance of operational amplifier is very high, so all this current will go here. Okay, so we will have a feedback current here, IF, and this feedback current IF is nothing but it is the sum of all these three current. Okay, so therefore I can write that IF. So initially I will write here as IF, that is equals to I1 plus I2 plus I3. All right. So this is the case when all the three inputs are applied. When some of them are not applied, then it depends upon like which unit you are applying. So you will have to see it properly, then accordingly you can give the current value. Okay. Now, before we move further, let us say this is the point, this point here, I'm marking it with different color here. What is the potential at this point? VA. I will call this as VA. Again, if you use the virtual ground concept, the potential at this point is 0 volt, isn't it? So since the potential to the non-inverting terminal is 0 volt, so the potential at this point using the concept of virtual ground, it should be your 0 volt. Okay, fine. So now this VA is 0. Now let us try to write down the value of output voltage here. Let us try to write output voltage. Okay, So now how you can write down the value of current IF? So this current, if you want to write, that means the formula for current would be voltage divided by resistance. And what is the voltage across this? What is the voltage drop across this? The voltage drop across this would be VA minus V naught. Okay, so VA minus V naught divided by RF. That is nothing but that is your current IF. So we will first write down the value of IF. Okay, so now we know that VA minus V naught divided by RF, because this VA minus V naught is nothing but it is the drop here. Okay, the drop across this resistance. So this is nothing but this is your value of current IF. Okay, so now you substitute here VA. VA is 0. Let me just do it here itself. So now if I put 0 here, so it will be just like your 0 minus V naught. Okay, so it will be 0 minus V naught. So in other words, 0 minus V naught is nothing but it is just V naught minus V naught. So you will get this expression here, minus V naught divided by RF is equal to your IF. So this implies that you can write that V out is equal to minus, you put this minus sign to this side, so it will be minus of IF into RF, or you can write minus of RF into IF. Okay, now let us put the value of IF here. IF is I1 plus I2 plus I3. So this implies that, so V naught is equals to minus of RF, and I am just putting the value here, I1 plus I2 plus I3. All right, so these are my values. Now I'm trying to write I1 in terms of my you know that current is equal to voltage by resistance, is not it? तो अगर मैं यहाँ पर देखूँ तो I1 में कैसे लिख सकता हूँ? I1 is nothing but it is V1 by R1, and I2 is V2 by R2. Similarly, I3 is V3 by R3. Okay, so therefore I will just want to replace this minus of RF, this V1 divided by R1, plus I will have this as V2 divided by R2, plus this as V3 divided by R3. Okay, now all right, this is the thing which we got here. Now see, if you select this input resistance equal because I want to simplify the expression. Actually I'm designing, remember that we are designing a summer amplifier. How you can make this a summer amplifier? There is only one possibility, that because if you can take all these outside, but if they are different, you cannot take it as a common outside, isn't it? So to make this a common quantity, you need to take all these three an equal quantity. Okay, if I say that R1 is equals to, let us say R1 is equals to R2 is equals to R3. So let us say that this is some value 40-50 kilo ohm, we don't know that. In general, let us say this is equals to R. Okay, so now in place of all these, you can just write R here. That means I'm assuming that all the resistances which is connected here, they are equal value. If this is 4 kilo ohm, this is also 4 kilo ohm, and this is also 4 kilo ohm. All right, that is what we are assuming here. So if this is the condition, then here also you will have just R, here also you will have just R, and here also you will have just R. Now, so that you can take this R common outside, so therefore you can write that V naught is equals to minus of RF divided by R. Okay, just R. Then inside you will have V1 plus V2 plus V3. Now you see this expression carefully. The output is proportional. I cannot say that equal to, because there is some constant quantity also here. I cannot just say that the output is equal to the sum of the input voltage here. Till now I cannot say. Now what I can conclude is that the output voltage is proportional to the is proportional to the sum of the input voltages. These are the input voltages I am applying. Okay. Now, if you want the output to be equal to the sum of the input voltages, then these two should be equal. That means you will have to design an amplifier with unity gain. You will have to design an amplifier with unity gain. That means you need to take the feedback and all the input resistance same value. Okay. You need to take, if you take this as 4 kilo ohm, all this you should take it to be 4 kilo ohm. 4 kilo ohm, 4 kilo ohm, all this 4 kilo ohm. Then if you give any input voltages here, the output would be directly the sum of these input voltages. Of course, there will be a negative sign. That negative sign comes because of non-inverting amplifier, but that negative sign does not harm your calculations. Okay. So now if this is the condition, let us say that when the gain is unity. So if this is the condition, if the gain is unity, that means I can write that the value of RF should be equal to all these three values. R1, they should be equal to R2, and it should be equal to R3. Okay. So let us say all these are equal. Now, if these are equal, then they can get cancelled out here. Okay. This RF and R1, this may be R1. So let us say, okay, it may be R1, R2, R3. So they can get cancelled out here. So now if it get cancelled out, then what would you get? You will just get a 1 here. So you will just get a minus of V1 plus V2 plus V3. Now you see this formula. Now, if I am designing in such a way that my input resistances, all the input resistances are equal, and the value of the feedback resistance is also equal to the input resistances, then you can design an amplifier which will give you the sum of the input voltages. Okay. So now I can say that the output is equal to the negative of the algebraic sum of all the input voltages. Okay. So this is how you can design an amplifier to be an adder. This is also known as adder. Okay. Or it is also known as summer. Okay. So in different books there may be different notations for this one. So this is about the summing amplifier. So now based on this summing amplifier, I have also given, written some of the questions, like some of the numerical questions, very simple questions. Okay. So let us try to see this. Just one question I would like to discuss with you all. Then we can conclude this today's session. And from the next session, we can look on something like, again, the application part of this summing amplifier. Okay. So let us say we have an amplifier, which is a summing amplifier, in fact. So yeah, and at this terminal, I will now have यहाँ पे दो resistances connect होगा. Okay. I'm giving the input here. So let us say this is my 0.2 volt. I'm giving some voltage here. And let me say that this is my 0.5 volt, some voltages here. Okay. So, all right. I will have the feedback again. So this is your feedback. And it is 10K. Feedback is 10K. And these are 1K and 1K. So you just need to find out the output voltage. Okay. Now, since you see here, if all the resistances are equal, if 10K is equal to, again 10K is equal to 10K, then you can directly write the formula as minus of V1 plus V2. But here in this case, you cannot use this formula because RF is not equal to R1 and R2. Although R1 and R2 are equal, to be a proportional to sum, these two should be equal. Although they are equal, but it is not equal to your RF. So therefore, you cannot use this formula directly. Instead, which one you will have to use? The previous one, which I have just now, which I have derived, that you need to use this. V out is equals to minus of RF divided by R I will just write R. So this R may be equal to R1 or R2 since both are equal. Okay. So then you will write V1 plus V2. Just use this formula. Put the value of RF, that is 10K. Put the value of R, which is R is equal to R1 and R2, that is 1K. So you will get minus 10 here. So V naught. Oh, there is some. Right. Sorry for that. So here you will get V naught, and then yeah, minus 10 you will get minus 10 by 1, that is 10, and then just put the values of these two voltages. Okay, so यहाँ पर आएगा 0.2 और यहाँ पर आएगा 0.5. So in this way you can calculate, you can do the calculation by yourself here, this one. Okay, around you will get minus 7 volt here. So in this way you can do the calculation. Just you need to remember before you use the formula. Now let us say that this is also not equal. Suppose in this problem itself, I am not giving you any extra problem, but in this problem itself, I am giving you that this is not equal. Let us say this is 0.5K. Then which formula would you use? You cannot even use this one. Okay, you cannot even use this formula. In that case, you may have to use this one, the earlier one, like V naught is equal to minus of, because neither R1 equal to R2 nor RF equal to all these quantities. Okay, so you may just have to use that. RF is okay, RF is outside, you can take outside RF, but you may have to use in this way: V1 divided by R1 plus V2 divided by R2. Okay, so this would be appropriate if it is 0.5K and 1K. So you must know when to use which simplified formula. Okay, so in that way your calculation will also be easy if you can immediately identify this. Otherwise, if you in everywhere if you use this formula, then it may take a little bit longer time for you to calculate it. Okay, so just by looking the circuit diagram and identifying the proper value of R1, R2 and RF, you must know which formula to use it. So I have also given one more questions. You can just look it by yourself. I'm not going to discuss that here. Okay, and in the next class we will try to see the application part of this summer again. There are few applications like average amplifier. Okay, how we can use summer as average amplifier. Those things we will try to see in the next class. Okay, so I hope that this session was clear to you all.
Yes, sir.
Yeah, okay. Thank you for the response. So I hope it is clear to other students also. So I'm just stop sharing the screen now, and I'm just stop presenting. So okay, with this we come to the end of today's lecture, and I will see you soon in the next one, in the next lecture. Okay, where we will, as I mentioned that, where we will discuss the average amplifier, which is also an extension of a summing amplifier. So all right, thank you everyone, and see you soon in the next class. Thank you all.
Thank you, sir.